while it's being executed. Major tools that are used there is volatility framework, whereby we have to capture after executing the memory, the malware, so you can capture the memory and use volatility to analyze the memory so that at least also you understand when the malware is loaded in the memory, how is it? And what are the keys? Moving it, you restore the operating system. Then from there, now you return the infected machine back to the network. Sometimes malware forensics is also important because sometimes we use it to collect the evidence for investigation. By any chance, now we have known maybe who is the person who was responsible for sending this malware, based maybe on the IP addresses or the domains. Then, and also sometimes you can find maybe a Trojan that collected information and sent to a specific person. So you can continue with that investigation so that you take it to a court of law for prosecution, because now you have known the key suspect who was sending the malware to your system. So there are different types of malware analysis strategies that are employed. The first one is static analysis. Static analysis, malware analysis majorly is just you analyze the malware without executing it. That is static malware analysis. Then we have dynamic malware analysis, whereby we analyze the malware by running it. When we run it, we understand its functionality. So you run it into sandbox environments that are safe for you to run the malware. There are already different sandboxes on the internet, like Cuckoo, AnyRun, and hybrid analysis that can be able, you just take the hash of the malware, then you put it there, then you can be able to execute it on that systems, on sandboxes that are already readily available on the internet, online. In dynamic analysis, we just run the malware. We understand its behavioral analysis. So we do behavior analysis so that at least we understand what are the different registry changes it's making on the computer system, and what are the file changes the malware is able to do on the computer system. We understand its process activity and then the network traffic that is able to send out while it's being executed. Major tools that are used there is volatility framework, whereby we have to capture after executing the memory, the malware, so you can capture the memory and use volatility to analyze the memory so that at least also you understand when the malware is loaded in the memory, how is it? And what are the key areas where it's affecting maybe, on which files is it creating on the computer system. Then the last one is reverse engineering. Reverse engineering is whereby we have to disassemble the malware. So there are different tools that are used to disassemble the malware. We just like disassemble it so that at least we understand its flow, its functionality at code level. So there are different tools that are there. We can do maybe during disassembling, we can do signature-based analysis, also static analysis, where we just go through the code and understand, is there any maybe obfuscation whereby the code is encrypted? So you analyze it more so that you understand its functionality. So that's in a nutshell, in simple words, what is malware forensics. So before we start practical, is there any question related to malware forensics? Good. If there is not any question, then we can go ahead and do the analysis of malwares. So how do you create now a safe environment for you to analyze the malware? So the first thing that you have to do, for me, I'm using a VirtualBox. It's a virtual machine that I have created for malware analysis. We have a Windows machine. This Windows 7 I have created for malware analysis. So I've created a Windows 7, then put all the malware analysis tools. We have Remnax. That's a Linux system for malware analysis. You can download it online. It's readily available as an OVA file. So you just download it, then you import into your VirtualBox. So how do you create a safe environment for malware analysis? So the first thing that you have to do is to ensure that the malware, your system, does not connect to the internet. So within a VirtualBox, you have to go to the network and ensure that you have put on host-only adapter. Host-only adapter ensures that your computer does not connect to the internet, and it does not also communicate to your guest, your host computer. If you have installed a virtual machine, so a virtual machine is the guest operating system, then your computer now is a host. So you ensure that you have put host-only adapter so it doesn't communicate to the internet and does not communicate to your computer. There are different adapters that are there. NAT is just those good in networking. It's just network address translation. So it NATs your IP address, your host IP address, and it's used to connect to the internet by the guest operating system. Then bridged, it's just bridging. It's just creating a bridge between the IP address of your computer. Maybe it's 192.168.10.11. Then when you are using bridged, it's just creating another IP address on a bridge. So it will be maybe 112. Then internal network, this one it creates within the host machine. It can use it, but it also communicates to the host machine, but does not connect to the internet. So host only, this is an adapter, network adapter that allows the host machine to have its own IP address. And this IP address does not connect to the internet and does not connect to the host machine. So you always have to ensure that you are using host-only adapter. And you ensure that adapter 2 maybe is off, this one is disabled, this one is disabled. Sometimes you might be thinking that adapter 1 is on, like you have used host-only, but you find yourself, maybe you have enabled here and it's breached. So it means that it can communicate to your host computer and again communicate to the internet. So by any chance there is any infection, your host computer will also be infected. Then the other thing that you have to ensure that there is no any shared folder. You don't share any folder with the host machine. By any chance the virtual machine is infected, then it means that any shared folder here on your host machine will also be infected. And the malware will spread to your computer. So that's how it is. That's how to set a safe environment on VirtualBox for malware analysis. So I'll power on my virtual machine. It's taking some more time. But the key thing is you have to prepare your environment. By any chance you want to set up your own virtual machine analysis for malware analysis, you have to create an isolated lab environment, as I've shown you. You also have to ensure that you take snapshots. You have to create snapshots all the time. Like this now, because before I run the malware, I have to take a snapshot. By any chance this system will be infected, then I can fall back to this snapshot. So I'll call that snapshot 1 because I'm going to run some malware. So even if it will be infected, I'll be able to run back the other snapshot and restore the system. Okay. Good. So these are the different tools that are used to analyze the malware. So the first thing, by any chance you have detected a malicious file, the first thing that you'll do is the initial triage. Like you have identified any place, maybe there is a malicious file that you don't know it, and you suspect maybe it could be a malware. The first thing you have to do is you understand the file type. File type is important because a computer system identifies the file type, the file signature, and identifies that file and which application can be used to analyze it. So the first thing that you have to do is triage, where you have to use a tool called HXD. HXD is a tool that allows you to view the binary of a file. So I'll just open an example file here. Let me open this one. So there is something called file header and file tail, or file end. So this is how a file looks like. All the files maybe you have on your computer system, this is how they should look like. So the first 5 bytes, this one, it identifies the type of the file. When you see it's an MZ, it means that it's an executable file. So every file type has a header and a tail. So it's good for you as a malware analyst to understand what is the file header, maybe of a PDF or of an executable file, or maybe a Word document. Because sometimes malware creators, they are very tricky. They can put 2 files here. They can just take a document like a Word document, then inside that Word document, they have maybe an exe file. So while you open that Word document, you think it's just a Word document, but there is an exe file that is able to execute in the background. So you have to understand, by checking the file headers, then you go down here and check the tail of the file. Here, this is the tail of the file. So by analyzing the file header, you are able to understand, by any chance, there is any files that are hidden within the file. So that's the first thing that you have to do. And you have to go maybe on the internet and understand. I hope you can see my screen. Yeah, good. There is a database for all file signatures. So you have to go down here. These are the file signatures. There is a file header, then there is a tail. So you have to understand all this. Like when you see a file, sometimes malware creators, they can create, maybe it's a PDF, then they change the file format. The file type now becomes maybe a docs, but yet it's .pdf. You as a malware analyst, you can use HXD to be able to identify the real type of the file, because you only have to check the signature, the head, the file headers. Then you'll be able to understand that this is a PDF, this is not a document, a .docs. Or sometimes they can create maybe an executable file and save it as .dll. So that's the first thing that you have to do. I hope that one is understandable. And some other time when you identify by any chance a file that you have identified, there is another file that has been saved, maybe a JPEG, and you have come to identify maybe the header of a JPEG is 48, 80 something, you just come up to here. You have identified the JPEG starts with the header here. Then you come, you identify its tail. You just select it, then you copy. Then you create a new file here. Then you paste it. Once you paste, you are able to save it. When you save it as a JPEG, you are able to open it as a JPEG file. So that's the first thing. The next thing that you have to do during triage, so that at least you understand more about a malicious file, you have to calculate its hash. So there is a tool called hash my file. What's a hash? A hash is just a mathematical calculation that is given to a file. So all the files, maybe if it's a Word document, maybe you have written only your name. By any chance you alter any other name, maybe any with just one letter. Let me show you. I don't know if Word is here. Let's use WordPad. Like your name is Mandela, just like mine. Then I'm going to save it. I'll call it document 1. Then I'll save here under documents. Then I'll close it. Then I'll open hash my file. Hash my file is, it calculates the hash. It computes the content of a file, then it allocates its a hash value. By any chance that content is changed, then the hash is going to change. Even if you alter one later, it will be able to change that hash. So it was under document. You see, this is the hash. If by any chance we take this file and change anything, like just remove this one later and save it, okay? And again, drag it here. The hash, this hash is going to change. So every file, the antiviruses that are there, they have a database of all the file signatures and file hashes. So they compare. By any chance, this hash, if by any chance we report this one as malicious, then every antivirus will get updated. When that file is within its computing system, then it's able to detect that this is a malicious file based on these hashes. That's how antiviruses work. So you, as a malware analyst, you have to come and understand. The first thing, when you have a suspected file, you have to calculate its hash. Once you calculate its hash, then you can use that hash to be able to check on the virus total as the first step to check if the file is malicious or not. So that's what you are doing, static malware analysis. Static is you analyze the malware without running it, without executing it. So I'll take a simple malicious file like this one is a malicious file that we was working on, but it's an old one. I wanted to check the new ones. Like this one. Then you can right click on it, then you can copy MD5. I hope it will allow me to paste, to share with the host. I don't know if it will allow me. I just calculated the hash and I'm going to search it on the internet to see if it's malicious or not. It's not allowing me. So what I'll have to do is I'll enable the internet on this host machine. Then once the timer will be executing the malware, I'll power off the machine. Kibet, what are you trying? Put on that. I'll try to open Chrome within here.
Mwalimu, just to get clarity.
Yes, go ahead.
If I follow the process, let's say this is the static analysis. So you've gotten the file that's being suspected. You run it through hash my file to get the signature.
Yes.
And then you're getting that signal. Now you're running it to the virus total to check whether
Malicious or not.
Okay. Okay.
Yes.
Good
Yes.
to know
Yes.
that. Thank you. Thank you.
Yeah. Good. So we are pasting the hash there. Then we search on virus total. From there, you will see that the file is malicious. These are the results of virus total. 56 out of 71 antiviruses have detected it as being malicious. Then you come to detection here. You will see which type of malware is it being detected. It's a Trojan. So once you identify it's malicious, now you want to collect more information about it so that at least you understand its functionality. These are known malware. When it's known and it has already been submitted on virus total, then you can just go on details so that at least you understand it much more. You can see that a file type is Windows 32. It was designed for System 32, Windows 32 processor. Then you can be able to see when was it compiled, when was the malware created, what was the tool that was used to compile this malware. They compiled it using Microsoft Visual C++. Then timestamp, the creation time, it was created in 2010. Then if it's 2010, it means that it's a known malware. But if it's a new malware that was created maybe yesterday, virus total will not give you a lot of information. It will only be able to detect because there are some systems that automatically detects based on the injected code in a software. So based on those injected code, some malware, some antivirus like Kaspersky are able to identify that. Once it's able to identify, it updates on the databases that is suspected file. So when you come to test, you'll be able to come and see here maybe detection. Maybe you'll be able to see maybe out of maybe 5 out of 10 or 1 out of 70 is able to detect that file as malicious. So you have to go and run it yourself so that at least you can be able to record its activities, understand its functionalities, what are its network activities, what are the file activities, what are the registry activities that this malware creates on the computer system, and how does it flow? So that you come here as in the community and update it. So that's the detail. So the malware was created this, and the first time it was seen was in 2012. This is the first time it was detected as malicious. The first time it was submitted was the same time in 2012. So it means that for 2 years, this malware worked without being detected as being malicious. Now that's one, you have to understand the morphism of a malware. It can be there, taking it, doing its activities on computing system. The malware developer is getting everything they were intended to have. Within maybe, just imagine 2 years, nobody detected that it was a malicious file. Then these are the different names that has been named. Then you come here, there is PE header, portable executable info. So here you get the different information about that specific malware. It's majorly it's about when like it was created for Windows 32 or System 64 processors or what. So this is the header information. A malware always has different sections. There is .text, there is .data, and there is .data. See, these are just different sections where it stores information while it's being executed. And it stores that information so that when it's running, it's able to import some functionalities on the computer system. So .text section in a malware, what it helps it just contains the executable code, the instruction, machine instruction when the malware is being executed. So that's where .text section contains. When we will reverse engineer this malware using maybe IDEA Pro or Jidra, we will be able to see all these sections: .text section, .r data, and .data. So a section, the text section, it contains the executable code, the machine instructions that the malware works on while it's being executed. So it contains maybe the malicious logic, maybe the payloads that it has to send or the exploits. And also majorly it has the entry point. Entry point is the point at which the malware starts executing. It starts its activities. If maybe it's a Trojan, it's a it's a Trojan. So at what point does it start collecting information about the target? The dot section, majorly it stores global variables that are initialized. So it's just global variables that the malware needs while it's executing. Majorly, it stores hard-coded values like decryption keys, IP addresses, and the flags. Then the .r data section, it contains information that are read-only for the malware. Majorly, it's always used to pack the malware. Where the malware is packed, to ensure that the malware analyst doesn't understand the code much more, it's the data that is packed. Then we have the imports and exports. So this malware, while it's being executed, it imports these functionalities from the computer system. So the imports majorly, they are just functions and symbols called by the executable file while it's being executed. If you are good in programming, you'll understand the variables that are called upon by the program when it's being executed. So it aids it in its functionality. So those are the things that you'll see. It's good you understand the imports, because if you see an import like kernel 32, it means that the malware interacts with the kernel of the computer system. You can go inside and see this one. I think it just handles the handles of the threads of the processes. Then there is also exports. The exports majorly are just the function and addresses that the binary provides for others to call upon. Maybe just global variables for those in programming. You can be able to explain that about a malware. So relations, it will give you information, maybe what are the different IP addresses the malware contacts, what are the files that it creates on the computer system, and the IP addresses and domains that it's able to contact while it's being executed. So you as a malware analyst, if it's a new malware, when you come to details, you'll not be able to see anything here. So you have to go and understand what are the different IP addresses that this malware contact when it's being executed. So that's what we will be doing today, so that at least we understand. And what are the file changes that the malware does on the computer system. So you have to understand everything like this. Then from there, you can now document a report about the malware. Then from there, now you can recommend, now that you have fully patched that malware from the computer system, and you return that infected machine after removing the malware, you return it back to the computer network. So that's VirusTotal. Good. I thought I had closed the computer. So there are other tools now. Which tools, by any chance, the malware is new, that gives you all the information that we have seen on VirusTotal? If the malware is new, the first thing that we have to use, there is a tool called PE header. There is PE viewer and PE header. So we'll start with PE. I just take this one first. This one will give you information about the target machine. The tool called PE view. It will give you the information about the target machine that the malware was meant for, when was it created, image based, where it will start maybe the entry point, then checksum, it will check it if it is it incorrect or correct. If you see it's incorrect, then it means that this malware is packed. What do you mean that the malware is packed? A malware is packed. You say malware is packed by any chance, it's compressed. If the malware is compressed, so malware developers, they always compress the malware. The essence of compressing the malware is to avoid detection and at the same time also ensure that the work of a malware analyst to understand this malware is hard. So you as a malware analyst, you have to see, is it packed or not? If it's packed, you have to go and unpack it. So like this one, when you see this one, the checksum is incorrect. It means that this malware is packed. Even if you do what, you'll not be able to understand its functionality well. Then it also gives you the sections of this malware. So it has the text, the data, and resource. Then also it shows you the imports, the different imports, the DLLs that the malware imports while being executed. What are different function calls does it interact with while it's running on the computer system? PID, it helps you to detect if the malware is packed or not. Just take this one. You have to do deep scan. Like this one is not packed, but there is another malware here that is packed. I think lab 2. It's not. I'll just go and check the. Can you see this? So this malware is packed using UPX. UPX is a packer. It's a program that malware developers use to compress the malware, to hide its functionality. So when it's running on the computer system, you cannot be able to detect that it's running. And you as a malware analyst, when you check the code, you will not be able to understand its functionality. So the other thing that you have to do, we will be able to decompress it so that at least we see how it looks like. But if by any chance you're analyzing such type of malware and you want to see maybe its strings, there is a tool called strings that helps you understand maybe the binaries. You have to use it so that at least you see. Let me use strings. You can use strings or binwalk. Not install. There is one called binwalk and strings. Let me just see here. Not executing, I don't know why. Good, we can just look for it, then we run the strings directly. So that's the malware. When you check its strings, you see they are so limited. They start from here and ends here. So those are the first indicators to know that the malware is packed. It doesn't give you a lot of information. Is there a question? Yes, go ahead. Was there a question? Okay, I'll go ahead. So when you're analyzing this malware, you'll see that it is giving you little strings. Strings are just the words within the malware, like words that you can be able to understand when you look at them. So when you analyze the first thing, like you see maybe UPX, you'll know that this malware is packed maybe with UPX. Then you can see maybe sometimes you can just analyze the strings, because when you're doing static analysis, you just want to understand more information about a specific malicious file without executing. So when sometimes you check the strings, you can be able to identify maybe the IP addresses that it's able to contact or the domains, because it will be able to display. You can also find maybe the URLs that the malware is able to contact, like these ones. So it gives you maybe a hint that this malware is able to contact, maybe connect to a specific IP addresses or domains while it's being executed. So you start, once you identify maybe IP addresses or domains, you can be able now to go to who is online and check which sources are they associated with. Collins, I'll have to mute you. So that's what you have to do. Strings give you readable information about a specific malware. If you see the strings are limited, small like this one, it means that the malware could be packed. So you have to confirm with PID, like the way we did confirm with PID, and we saw that that malware is packed. So how do we unpack it so that we understand its functionality? So you find out first with PID. Sorry. So this is the packed malware. You see its size also. While you're doing the static analysis, you have to check the size of the malware. If you see the size is small like this, it means that it's probability it's packed. So I'll copy it and take it to and let to see where UPX is so that we can use it to unpack. So since we used PID, this is the tool we used to detect that this malware is packed. So you have to come at deep scan. You see it's packed with the UPX 0.89. So we have to unpack it. So once we find that it's packed with the UPX, you download UPX and use it to unpack it. UPX is freely online. It's available as a free source. So you can use it to unpack. So you put UPX, then you put -D. It stands in decompress. Then you put the name of the malware, like that. You see it successfully unpacked. When now you see the size of the file, it was 3 KB, but see now the size of the file, it's 16 KB. If we check its strings now, it will be able to give us more information about this malware. You see now it has more strings. You see, these are some of the IP addresses it's able to contact. And some of the content we can be able to see, though it's still obfuscated, but we can see at least the DOS. It's an executable file. You can also see some of the imports that the DLLs that it imports. You can also at least guess what it does on the computer system. So it gets system time to file time. Then from there, it creates waitable timer. Then after that, it exits the process. It opens on a mutex. Mutex, it means that it hides itself on the computer system. Maybe it can maybe create an auto start in the computer registry. Then it creates a thread on the computer system. Then it creates a service A. Then it starts that service. So you can be able to understand, even without executing this malware, what its functionalities are on the computer system. At least you have a hint that it creates maybe a process, it creates a thread, and after creating that, it gets maybe the system time name, it gets a module file name, it gets maybe a file, a specific file. Then from there, we have also seen that it has a URL. So how does it contact this URL? So that's static analysis that you have to do. The other tools that you have to use is the DLL list. I think it's here. No, it's P Studio. So P Studio will give us all the header information like what we saw in VirusTotal. By any chance the malware is packed, it will give us a lot of information. So rather than running VirusTotal, you can come here, because here it will show the indicators. Here, the first thing it will do, it will give you the hash of the file. Then it will give you maybe when was it created, the timestamp of the file, and the CPU that it was meant for. This is the compile time, when was the malware created. Then you come here, why is it indicating that it's malicious? What is it looking at to show that it's malicious? So it saw that the strings was limited. So the count of strings is suspicious because they're small. The reference strings tagged as blacklist. Some of the strings that it's within that file are already blacklisted in some databases. The reference library also is on blacklist. The file import symbols are also tagged as blacklist. Then we have file reference URL. It references a URL, the URL that we saw there. The file contains a rich header. Then there are several APIs that it calls. That's why it's being detected as malicious. Okay. Then you can come here and see the DOS header, where you'll see the MD5 of the file, just like the hash of the malicious file, the one that we used hash my file to get them. Then you'll get here the entropy. The entropy majorly in malware, if the entropy is around 7 point something and above, it means that this malware is encrypted. But if it's not encrypted, it will have an entropy that is less than 7 point. Then here it will show you the rich header. It will show you which tool was used to compile this malware. So they used Visual Studio to compile it. Then you'll come to see the sections of the malware where we were seeing the rdata.textdata.resource, the different sections where the malware stores different information. Then we have the libraries. These are just what does the malware call when it's being executed, or what does it refer externally when it's being executed. So we have the imports and the exports. So this one is just counting the imports that this malware is able to refer to. You see, like when you come here, you'll see that it contacts the network. So it means that this malware is able to connect to the network. So we have to, during our execution, we have to use different tools to be able to see what does it contact on this network when it's connecting online. Strings, this is just like what we saw. So this tool is also able to give you the strings that this malware has inside it. These are the different strings. So that's PE Studio. It gives you a lot of information about a malicious file. Then while we are still doing static analysis, there is another tool called CFF Explorer. It gives you the same information like PE Studio, but at least sometimes it gives you refined information. When specifically maybe the file timestamps it's able to give you. This is the first time it was created. But we created it today on the computer system. No, we created on the computer system on May 18th. And which type of file is it? Tool that was used to execute, to compile it, to be able to give you that. And what is it? MD5 and SHA-file. It also gives you some information about the header information, like what we just saw, the sections of the malware, the timestamp it was created, when was it created, and everything is there. Then sometimes it can allow us to decompile the malware. This one. So if the malware is compressed, let me put the one that we have not decompressed. You will see the difference. Just a second. It was supposed to give us an option to unpack. So the compression level is level 7. Okay, we are still on the first one. Just a second. Yes, you see here, it has detected that it's packed. So it's checking if the executable is packed or not. So it gives us an option to unpack. So you can use UPX on timeline, or you can use this CFF Explorer to unpack the malware if it's packed. When you see a malware, maybe it's packed like that, it gives little information about itself. It has already shown that it was packed by UPX. It's showing that it was created in 2023, which is not true. Compared to when it's unpacked, you can see the true information about the malware. The creation time was this, then this is when we are able to put it in this computer system. So that's static basic analysis. Is there any question after that basic static analysis? So basic static analysis, we just collect as much information about the malicious file so that at least we understand it more without running it. Is there any question up to that level before we go to dynamic analysis?
Yeah, maybe to ask, is there an order of using these particular tools so that you can be able to gather information? Because some of them seems to be having more details than the others. So is there hierarchy of the use of the tools? Maybe once you use one like just in the CFF is giving some information that we could be able to additional information that we're able to get from the other tools. So based on your experience and advice, I know right now we are learning, so we'll use all of them to a number of them to just get a grasp. But in real life situation, is there a chronology or hierarchical use of the tools when you're doing the various analysis, like the dynamic?
Yes,
the static down that you given.
Good question there. Most of these tools, sometimes it can give you specific different information. So if you're using the major tools that I use majorly or static analysis, I use CFF Explorer and PE Studio. Those are the major tools I use. Because if you want to use bin text or strings to give you the strings, then CFF can still give you strings here when you're analyzing it. It will be able to give you the strings. Some of the strings are this side. Then when you are using PE Studio, it gives you more information just like this one, but it does not allow you to unpack if the malware is packed. So the major tools that you have to use during static analysis is just CFF Explorer and PE Studio. And sometimes a CFF Explorer will not detect if the malware is packed using other packers, because for it has UPX utility to detect. But if the malware is not packed with UPX, then you have to come and use PID. PID is the only tool that can be able to detect if the malware is packed or not. Let's take another one. Sometimes you can find like it's packed using FSG. It's a different packer. And when you put the same malware in CFF Explorer, it will not detect that it's packed using FSG, because for it has only UPX utility. So sometimes you have to use several tools to be able to understand the malware more. The first thing you have to do is just to understand its strings. The first thing you have to do is calculate its hash. Go virus total. Check, is it malicious? Is it already detected as malicious or not? If it's already detected as malicious, use virus total to understand its functionality.